Thank you very much for being here in the last session of the day, despite the amazing coffee break before. You are really the brave one. And the title of my talk is Kubernetes Beyond. And I would like to start this talk telling you, like 30 minutes, the history behind that talk. Because to be completely fair, I've decided, watching that movie, which is Star Trek Beyond, that I should have definitely have done a talk called Kubernetes Beyond before actually having a clear idea of what I wanted to talk about. So when I applied to the call for paper for this conference, I said, OK, so this is the title. Now let's figure out the content. So it was really the other way around. And I really started thinking about the concept of beyond in Kubernetes, trying to make some parallelism and some comparison with the concept of, the enterprise, the Star Trek Enterprise Starship, that really which scope is really to go beyond the border of the galaxy to discover new species. And I said, well, I think somehow Kubernetes can be like our galaxy. Maybe there are other ways of using Kubernetes. So let's think about how we can move Kubernetes to different use cases from the original one. And this is really what I want to talk during this session, And I started really from the Kubernetes homepage. Have you ever spent some time reading the homepage of their website? I mean, it's an amazing piece of marketing. There are amazing words, amazing messages in this homepage. I think it's one of the best one of ever for, open source project. If you look at the linux.org homepage, is really confusing because everyone knows Linux, but Kubernetes has been really, really successful. It is really, I think, even better than Docker one. And I did some research and I isolated some key messages on that homepage, on that website. And the first one that is really the key one to me is that statement, production-grade container orchestration. What does it mean, production-grade? Have you ever thought about it? I did, because of this talk. And then there are other statements like automated container deployment, scaling, and management. We all know that Kubernetes does it. Group container, and blah, blah, blah. This is really microservices. Then planet scale, this is Google. Never outgrow, this is marketing. Run everywhere again. But production-grade container orchestration, is that a flame toward Docker? I don't think so. I think this is really the statement of the mission of Kubernetes, to build something not perfect, but with production in mind. Okay? And we all know this component of Kubernetes. We all use, maybe if we use Kubernetes, we all use part of this component to break down the infrastructure requirements for our application and to model them to the Kubernetes domain. But production grade, I don't think it's about this thing. These components are more about the group container that make up application into logical units. So it's more about, the standard functionalities of Kubernetes are more about what is reasonable as service for an application, as infrastructure service for an application, and what is reasonable in terms of functionality the infrastructure should, standard functionalities the infrastructure should expose, and these are the functionalities. I think production grade really means that by design, and this is something Docker cannot do, by design, Kubernetes has been really conceived to be flexible and adapt to specific application requirements. Specific application requirements because my applications are not the same as yours. Every application has specific requirement in production, specific workflow in production to manage its life cycle. And for that extent, I think really production grade in the Kubernetes domain means that Kubernetes is an orchestration framework. It's something that already has embedded most of the component we need, 95% of the things we need. But then, and this I think is really a value of Kubernetes, it helps us also to cover that 5% of mission functionalities, providing us, as a framework, extension point to implement what we maybe miss to manage our application in production. So this is really the background, and what I think is really the parallelism between the enterprise and Kubernetes. Because Kubernetes, I think, is like the enterprise. I mean, it has infinite capability. Kubernetes has infinite capabilities and allows us really to move over more farther than ever in the infrastructure management, thanks to this integration point. So who I am, I think it's almost the time to say so. I'm Andrea Tosatto. I work with Power DNS, that if you don't know, it's really the bloody DNS. It's a bloody DNS implementation, so nothing so fancy as Kubernetes. And I work as DevOps, mainly as DevOps, leading the services team in Power DNS. So I work really on enterprise and telco project. And why I'm talking about Kubernetes is because I'm really obsessed about orchestration. I've implemented multiple orchestrators in my life, including orchestration of DNS. And I really like Kubernetes, the way it's implemented. And every time I can, I spend time studying Kubernetes and understanding its model, because I think it's one of the most powerful pieces of software, open source software, really lending to the community. And it's a really cool project. So, as we already discussed, this talk is really not about what we all know about Kubernetes and the standard interfaces, the standard concept of Kubernetes, the API, but it's more about how Kubernetes can be pushed beyond the standard use cases. And Kubernetes, it's really nice as a project because, as I was mentioning before, in order to be extended, there is a lot of a huge effort in Kubernetes on standardization. And by design, out of the box, Kubernetes can be expanded in two directions. The southbound interface is basically the runtime, the interface toward the runtime. And Antonio knows everything about it because he's leading the development of CRI-O. And this is really interesting because it's basically we can have pluggable runtime in Kubernetes, replacing Docker with CRI-O RNC or containerd RNC. So this is really the southbound. So what is running our application? This is pluggable. But then there is another part, which is the one we will be focusing in this talk, which is basically the extension northbound. So how the Kubernetes API are designed and are conceived in order to allow the extension of the standard object we do have in Kubernetes through the definition of custom resources and the implementation of additional controllers that basically map the life cycle of these additional resources. So this talk will be really about this side, not that side. Oops. What's up? Oops. Let's do it again. Pum, 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 pum. No, penso che sia qualcosa sul cavo, sai? Ok, sì, vedo un po' di gente che... Ok, 5-minute break. Ok. Okay, awesome. So again, why should we do it? Because we all know that Kubernetes is already enough powerful, but why should we move beyond? And I think this is really, again, the main motivation sits in this concept of production grade. We don't have perfect application, stateless, broke down in microservices that can resist to any kind of failure, that can scale horizontally, and all these kind of things. And I think really, my personal take is that the world will still be different from that kind of application for at least 5, 6, 10 years. And and even if the real world will be still different, we have really the need to provide to the new world, to work on the future of the world. So we really need to experiment what we have now, different type of infrastructure. And so one of the motivation is that, of course, what Kubernetes provide us is not enough for all the application. Let's think about stateful application like databases. How do we add a node to a MySQL replica set? How do we add it? Is really adding something more, or it's more complex? Maybe for our application, we want to provide, because of it's super complex, we don't want to map custom logic. We want to provide databases as a service provided by the infrastructure. So that we can work with them in a different infrastructure, in a different scope, and still provide databases as a service to the Kubernetes cluster, completely in automated fashion. And this is, for instance, one use case. The other two motivations, the other two reasons are I think, more interesting, and then we will go deep into the concept behind, and is that very often we want to decouple the lifecycle management of an application to the definition of the Docker image of the pod and these kind of things to ease the maintenance. Because if we code script like the entry script in a Docker file, we code all the logic to cluster the application there. How can we maintain it? I mean, it's not that easy. The entry point script, it's okay, it's working in the Docker scenario, but it's super hard to maintain. I mean, and do we really want to put in there all the discovery mechanism or the clustering logic in a bash script started before the application? It can be super hard. And as I was mentioning, the other reason is that we have monitoring. We all have monitoring. What about defining monitoring as a service of the infrastructure, and we just declare that our application requires monitoring on that endpoint, and then there is a Prometheus service in infrastructure that automatically starts getting the metrics from this application and showing all the things? This can be also something interesting. And the concept behind, in particular, the second bullet point is really this concept, the autopilot pattern. Who has ever heard about the autopilot pattern? Nobody. Really? Antonio. Okay, so the autopilot pattern is really what Kubernetes in the end is enabling. Because if we think about replication controller or these kind of tools, they really, allow us to drive our application in production, control this application in production, and potentially also automate the application workflow, so the scale up and down, the healing, and this kind of operation. So these operations are not done anymore by the sysadministrator, but these operations are done in the end by the application himself. That knows its states, thanks to Kubernetes, and then knows how to heal itself, the application. So this is really the idea of the autopilot pattern. We will go deeper into that in a few moments. But the core motivation for this pattern is this question. Who knows better what is the life cycle of an application in production and how to deal with it, with its trace transition? Is the infrastructure or the application itself because of the developer designing, clustering, designing functionality in a specific way? What's the answer? What do you think is the answer? Is the application or the infrastructure? Yeah, indeed. So this is really the idea of the autopilot pattern. Because of the developer developing the application, they know how it should operate. So the idea is really of the autopilot pattern is the following. So the idea is to push automation and lifecycle management from the infrastructure to the application itself. Okay? Because in the application, there is all the business logic, and there are all the information needed to orchestrate the application. The autopilot pattern, this is the website. Joyent has done some product on top of this. It's something really applying to containers, but it was also before with the cloud, with the public cloud. Is something really interesting. I really recommend you to read this website. especially because of this statement, to which I don't agree. And according to this pattern, it's really like a pattern for fanatical people of automation and self-healing and these kind of things. That again, I don't think is the real word. The autopilot pattern states the automation logic should live within the application in the same repository. So it's really tied to the application itself. And I don't agree with this statement. I agree with the first one. So I think that the lifecycle management logic should be closer to the application, should not live on VMware, should live really close to the application. But I don't agree with the second statement, because then, in the end, if we obey to this statement, then, again, we are treating all the application as different, entirely different, which is not true. The application share most of the things. We should move only the really special things to the application, not in general all the automation. Because otherwise, again, our application really depends on the runtime, which is one of the reasons why we are using Kubernetes, because we want to harmonize the runtime, although we want to be somehow flexible. If I have Kubernetes 1.7, I don't want to depend on that specific version, because otherwise I have to maintain forever my application, forever, and this is tied, the application maintenance cycle is tied up to the Kubernetes one. So this is why we have the container abstraction, and we want to work on a higher level. And this is the reason, essentially, for this, if I find them out, essentially for the concept of pod, the service, and these kind of things that are general concepts. The concept of autopilot is mapped, then CoreOS did a huge... Who ever heard about the operator, by the way? Okay, so the operator is the mapping of the autopilot pattern to the Kubernetes world. The work on operator has been really pushed forward by CoreOS. And the idea of the operator is essentially this one. We don't want really to build the lifecycle management inside the application, but this is something that lives in the intersection between the application and the runtime. So if the runtime is Kubernetes, then we should implement something in Kubernetes that is specifically designed, a software component specifically designed to manage the lifecycle of that specific application. So these are still two separate components, but the operator really is implemented to target the specific Kubernetes environment. If we move to Docker Swarm, we need to do something different according to what Swarm provides. And so for that reason, basically, the operator is an extension to the standard functionality of Kubernetes, the standard API, to implement specific controller logic to manage this application. And the idea of operator is really that one. So the idea of the operator is to code in a Kubernetes controller all the domain-specific knowledge to manage this application in production. Again, in the case of the database, is where we code that if we want to scale out, I don't know, a Galera cluster, we have to add a new node to the Galera cluster. We can decide either to do the master, add a new master, or a slave, and these things are different and have different impact, and we need to know what we do. It's not the same thing, and this kind of thing. Okay. So what is an operator in the end? And this was basically also in the abstract of my talk. So an operator is basically composed by a custom resource definition, which is in Kubernetes the type of object that allows us to extend through metadata the standard Kubernetes API exposed by KubeHappy that is sitting here, plus a specific controller that, given a new object into Kubernetes that is completely new to Kubernetes, so Kubernetes does not know how to orchestrate or to deal with, implements basically the transition from the desired state defined in the customer resource metadata, from the current state to the desired state defined in the instantiation of the new object defined in the customer resource metadata. Okay? So the idea, we will go then into the example immediately, so this will be clear, more clear. Let's do it immediately. Oop. So for, I was initially, is that big enough? Do you want it more? Is that better? Okay, so initially I was really, I mean, it's the last session of the day. I was not planning to do really light things. I mean, at least not that many. But then I talked with Nicola Jarocchia and I said, okay, let's do things live, which is better. So here I clone a project which is called Kubernetes Manager. Kubernetes Manager is basically an operator that allows to automatically create Let's Encrypt certificate. Okay? And we will use this project as example. So as I was mentioning in my slide, we see here the operator is basically a custom resource definition plus a specific controller to manage that kind of resources defined here. So let's look at the custom resource definition here. What is a custom resource definition? So this is a custom resource definition. So again, it's a YAML file in which we tell Kubernetes we say that we are going to create a new custom resource that is available. It's namespace, so it's not a service available as a system service, but it's a service available for each namespace. So the resources must be scoped in a specific namespace. If I am in the namespace Andrea, I cannot see the resources in the namespace Antonio. And we define basically the name of the resources we are going to instantiate, certificates. But this says nothing about how we want to manage the creation of these resources. So we just tell with the custom resources definition, Kubernetes, that the cluster now will also manage this new resource type that is not existing. This is completely new. So if we create this thing, Kubernetes will digest this instantiation task and will provide us a new custom resource definition. If we inspect this one, inspect, it's inspect. No, the get is sorry. Describe, not inspect. So we see what Kubernetes knows of this object is basically that we have now this new kind, what we told him, we have this new kind of resource and that is namespace, nothing more. Okay. So now let's create a new resource of this type. So now let's assume that I want to create a certificate for opsfactory.io. And I want to create it with Let's Encrypt. And okay, for the DNS, I want to use the DNS challenge in Let's Encrypt. And for that reason, I'm going to use as DNS provider Google Cloud. This won't work in the real example because I'm running everything on Minikube because of the network. But anyway, this is the concept. So to instantiate this kind of resources, this is what we need. We need to provide, in the same way we do it for the pod, for instance, or for the deployment, we need to provide Kubernetes the specific specification of this new kind of certificate. So this request, the intent of this request is to generate a new SSL certificate for opsfactory.io, and Let's Encrypt will register as email address admin at opsfactory.io. Okay? This is what we'll create. And the certificate will be injected in a secret named certopsfactory.io so that I can later use this secret in my application to configure, for instance, the certificate in Nginx or in an ingress or wherever. Okay? So now I've created this resource. And if I if I ask Kubernetes to list the certificates in the system, in my namespace, I see the certificate there. You see, certificate is a new resource. This is not a pod. This is not a deployment. This is something new. And again, if I ask Kubernetes to describe this kind of resource, you see that, OK, the resource has been created because it's in etcd. But then, I mean, there are no information, nothing more, because Kubernetes does not know what to do with this kind of resources. OK? It's just the API are just creating resources of this type, registering them into etcd, and then nothing more. There is no scheduler, no controller for these resources because these are new to Kubernetes. It does not know what to do. So let's go back to the presentation. This is the reason why we need. OK. This is the reason why we need the controller. Because now we have told Kubernetes that we want this certificate, the desired state, but still it doesn't know how to implement the transaction from the current state to the desired one, because it does not know that resource. We will now go into the code of this operator to see how these things are implemented. And the idea is basically all to implement in the controller what is called in Kubernetes the reconciliation loop. And the reconciliation loop is really the underneath model of Kubernetes to implement the state transition. And in order to implement this reconciliation loop, we need basically four steps. The first one is that we need to connect to the API. OK, this is obvious. So the controller will be a standard pod. We will use a deployment to deploy it. So it's a standard application, but it needs to talk with the Kubernetes internal API because we need to see the creation of this object, the certificates. The second thing is that we need to create an informer. The informer is the internal object in Kubernetes, the internal object in Kubernetes that inform all potentially the other services that, OK, we have a new resource of this type. We need to schedule something for it. So the informer sits between the instantiation creation of the resource and the scheduling of the action for this resource in order to execute it. Without the informer, we do nothing because we are not scheduling the execution of tasks on this resource. And then the third step is to add an event handler, and the event handler, basically the informer, once the informer sees a new resource of the type certificate, will trigger a new event. Addition, creation, removal, these are the kind of the event. And for each of these actions, we need to map an event handler that implements the specific logic to create the certificate. In the case of this operator, it will call let's encrypt and will trigger the certificate challenge. OK? And in the end, the result of the step 3 is that we have basically performed the state transaction, and we need to write back this change of the state into Kubernetes, creating the new secret, for instance, and also mapping the creation into the into the certificate object in etcd in order to be sure that this is not rescheduled again. Okay, we have to inform that the task, the creation, has been completed. I will try to use VS Code for this thing. It's the first time of my life I use VS Code, so please be patient. Let's see if the first challenge is to zoom. Ooh. Okay, but I still want to see the file. Okay, so as we said, the first logical component we have to implement is the informer. How many of you are confident with Golang code? Ooh, better than the question before. Perfect. OK, so this is really the source code. This operator is implemented in these 3 files. The main, the kubernetes.go, and the processor are like a bunch of 300 lines of code for each file, so it's not that big. And most of the code is generated. So Kubernetes, in the Kubernetes project, there is a code generator for controller, so most of this code is generated. So you really have to fill the blank to implement your custom logic. Like the bold DB to track the information and whatever. So the first thing we want to see is really the high-level thing, which are here. So I want to show you the creation of the Kubernetes client, and it's this one. So Kubernetes is providing us already an SDK to develop our customer controller. All the clients are done the same way. Kubernetes takes care of the authentication, take care of everything, everything. So we need to create basically a new instance of the API, and this is done by basically this config here. And the important thing is that Kubernetes is able to negotiate the authentication for services that live within the cluster with internal cluster APIs. Okay. Yeah. So this is the first thing. So again, to go back, how to instantiate a new API client, it's like this line of code. Okay. Kubernetes for us wrap all the creation instantiation logic of the client. And the Kubernetes client object is the one we will be using before in all the important part of the code. Now let's look at what is an informer. As I was mentioning you before, an informer is this kind of component that look at the creation of object of type certificate and make sure to trigger an event to tell the other, to tell that there is a new object of type certificate and something must be done about it. So it takes care of the scheduling of action for the new created object. And the informer is implementing this piece of code here, 379. Here. 379. Here. So the informer is implemented within this function. And the idea is that what we need to do in the main, basically, in the main, we start this control loop. So we'll watch the creation of new certificate. And to do so, we launch this function here. And in here, you see there is this informer. And the informer is super simple. This is what we do. We basically, if there is the add function is a function that emit an event of type watch headed. So we say, oh, there is a new object in there. And so it's like really like doing nothing. It's like boilerplating this thing. Nothing special is there in this case. So we receive a new certificate and we say, hey, we emit a new event that says there is a new object. In case of update, we emit an event of type modified. In case of deletion, we emit an event of type delete. So it's really super easy. We say, I mean, we just need this level of abstraction because there might be controller that for the scheduling needs to do custom thing. Like you can imagine the virtual machine creation, writing a controller to create virtual machine. You need to do more here. But in this case, it's super easy. And then we have the informer. Then we have to look at the component that is ingesting this event to really trigger the certificate creation. And this one is basically implemented in this file, in the processor file, as implemented here in line 320. And it's super, super easy. So we receive an event of type certificate event, okay, which are the kind of event we are emitting. And what we do here, we have to process the certificate creation, and we need to make sure that we lock everything because we don't want to generate in parallel multiple instances of the same certificate. We want to process one certificate request at a time. This is also in particular important for Let's Encrypt. And we process the certificate, so we trigger in the case of Let's Encrypt the ACME challenge to obtain the certificate. And this is done. This is what we do, basically. This is all we do. Then after the certificate generation, we do one thing more. I don't want to go deeper. That is, we trigger basically a new event to tell that there is a new secret in order to let Kubernetes, the Kubernetes API, then deal with the new secret. But this will be done by the Kubernetes API. This is out of scope. Okay. So now, let's deploy this thing, and then we close. Thanks. So now what I'm going to do, I'm deploying this controller on the infrastructure. We have already an object pending. So what we see here is that the object was not yet scheduled, was in etcd but not yet scheduled, and what you see here basically is that now there is the controller running. I see there is a new object. I have not done nothing for it, and it start the let's encrypt ACME negotiation. And this is because we cannot update Google DNS from here. This will fail, but we have seen that basically the controller now there is a pending object. We have done nothing with it. We start scheduling action for it. Okay, and this is it. So let's close this thing. So to recap. Why this thing is important? I mean, the code can be scary, but I agree. But it's not that much, believe me. The important thing is that Kubernetes, that I wanted really to show you, is that Kubernetes is meant to be easily extended beyond the standard capability. You can argue that this does not look easy, but we had like 10 minutes. If you spend 30, you understand everything. It's super easy. And you have a generator for it. And the important thing is that, and I really believe in this because I'm obsessed. Whoever knows me knows that I'm obsessed with orchestrating whatever is not, it's different from container with Kubernetes. So this is really important to me. Kubernetes enable new orchestration like cycle management pattern that were not possible before. Think about this thing with VMware. It's super hard. Also in terms of network segmentation, because you need to access the management network of VMware and blah, 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 super hard. And that's really the conclusion of this talk, is that with Kubernetes, we can go beyond the infrastructure and really focus on the application, because even if Kubernetes does not fit 100% our use cases, what we need, we have the capability to extend it to, again, get the 99.9% of feature we need. Again, this requires some coding, but this is called Codemotion, this conference, so I believe we are almost all developers. So, okay, that's really our part of the job. Thank you.